All right. There he is. Hey, Bill.
Okay, can everybody hear me now?
Yes,
Yes.
And so, am I ready to go?
you are.
So sorry, everybody. My apologies. So, as you can see, the title of this talk is Confronting Climate Change Down on the Farm. And I'm hopefully in this talk going to try to find a balance between hope and fear. Alicia, can you advance it?
Yep. Sure can.
So I started MOOKSEA Farm in 1985. That makes us 37 years old this year in February. We supply seed to other oyster farms up and down the East Coast from our hatchery, and we sell market oysters all throughout the United States. We currently employ about 28 people, and we sell 2 different brands of oysters that you can see pictured down on the bottom. Next slide. And this is a wonderful aerial photograph of the Damariscotta River where we're located. And just above the Glidden Point there, you'll see the hatchery on the east side of the river. That's our land base. We have a lease at Days Cove up by the hospital, up on the upper left on the east side there. We have a lease that is right off Little Point, one off Perkins Point, and then we have a winter lease that is down near the mouth of the river at Peters Island. Next slide. So I want to first kind of give everybody a high school biology or maybe college biology.
I put it in again then.
I'm going to talk a little bit about the life cycle of an oyster and how we control that in our land-based hatchery. So looking in the middle there, you'll see the adult oyster in the lower left. And those oysters in the summer, when the water gets warm, they feed, they build up their gonads, and they pump sperm and eggs into the water. Those eggs are fertilized and develop into a free-swimming larva, which stays up in the water, drifting around with the tides and the wind and the waves until it develops a little eye spot, which you can see in that one in the far right, and a little foot. It's up on the corner of the white thing. There you up, yep, right up in there. Anyway, and then that eye spot tells it which way to go to get away from the light, and it goes down to the bottom, and it cements itself to a hard substrate, and then grows into an adult oyster. We control that process in our hatchery. We have brood stock that we spawn. We culture the larvae in tanks, and then they go through a process where they set onto little pieces of shell chip. I'll show you that. And I want to point out that goo in the upper right, that's their food. They feed on microalgae from the adults do, the larvae do, and the young juvenile seed also feed on that. And we have to culture that in the hatchery. So I'm going to describe all of that. Next slide. So the hatchery, I always explain, is really the engine that drives the business because it produces the raw materials that we need on the farm, the seed. And the microalgae is the fuel that runs that engine. Next slide. So microalgae, they're single-celled plants that are planktonic, phytoplankton. And traditionally, they're cultured in hatcheries using photosynthesis, which, if you remember back to high school biology again, you're taking light energy and using that to basically connect carbon dioxide molecules into simple sugars, which provide the building blocks and the fuel for all the algae cells making everything that they need. And the problem with that is that if you're doing that in a culture system, the energy that drives that process has to come through the surface of the container. And that limits how many cells you can grow in a certain amount of space. Next slide. So back in the early 2000s, we developed fermentation process that occurs in a pretty sophisticated clean room, where instead of using carbon dioxide and light, we're growing these cells using glucose. So we're bypassing that early step, providing them with oxygen. We grow it allows us, because you have the building blocks and the fuel throughout the whole culture, you're able to grow these incredibly dense cultures, which we take and put into a centrifuge and spin it down and create this green paste that you see on the right. And that has been a real key in advancing our technology, because it allows us to decouple the production of the food from the husbandry of the animals that we're growing in the hatchery. So in most hatcheries, and the way we used to do it, you were growing the food as you needed to feed it to the animals. So if something happened, it was always a problem. This way, we can put this stuff in the freezer and pull it out and feed it, you know, at any time after we've frozen it. So it's great. Next slide. So the process with the animals starts with the brood stock, as I mentioned before. This is our brood stock room. We hold all kinds of different genetic strains, and we do a lot of selective breeding. We're breeding for hybrid vigor, fast growth, nice shape, disease resistance, and also more and more there's interest in breeding for animals that are more viable in an acidic marine environment, which I'll be talking about later as well. Next slide. So this is the spawning, and Alicia, I don't know if you can do it. This is a video. If you hover over that, hit the little arrow and start the video.
All right.
It's a little tricky. Yep. Okay, for some reason it's on its side, but here we're spawning these animals. These are females, and you can't see them because I should have rotated that picture. However, it's upright on my PC where I did it. What you'll see is the white cloudy material in the water. Those are little tiny eggs that it's flapping its shells together and spewing them into the water. So you can go to the next slide, because that didn't work out too well. So these are the larvae. This is the first critical step. These are swimming around in the water, filtering the phytoplankton out of the water. And this is a very vulnerable life stage. And we grow them for about 2 weeks in a tank, in different types of tank. Actually, next slide. The tanks on the left and the right, these are flow-through larval cultures. We can hold lots of 15 million in one of those tanks. And we're constantly putting in nice warm seawater and injecting food into the tank. The little green sieve on the right, that keeps the larvae from flowing out. And we grow them until they're ready to set. If you go to the next slide. These are big screens, and we put finely grated shell chip, spread that all over the screens. You can see the dark brown, those are oyster larvae that have attached and started to grow. And the picture on the right is an actual very young juvenile oyster, and you can see the little piece of shell chipped on the lower right of its shell. And you can see the food that it's filtered out of the water in its gut, and you can even see some poop that it's created for us. Next slide. So after they come off that setting system, we screen them off on fine sieves, and we put them into various juvenile culture systems where, and through the years, we've tried to get very efficient space-wise. So we're growing them in upflow silos, and those are pictured in the 2 photographs on the left. In the right, that's our Coke bottle system. There's water being forced up through that whole column of oyster seed. And when that thing is operating, it looks kind of like a lava lamp. The oysters are actually circulating around in there. It's a very efficient way, and you can come in every day, and we mark lines on there, and you can see how much they've grown from the previous day. It's quite remarkable. Next slide. So then we take that seed, and you can see a sieve, a bin of that up in the upper left there. That's what comes out of the hatchery, and we put them into different types of gear on the river. In the lower right, those are called Zapco tubes, and that's that Days Cove lease up by the Miles Hospital. Those float, they're anchored to the bottom, and when the tide comes in, they float up, and the oysters are moved around in there. When the tide goes out, They air dry, and that's how we control fouling. The trays, the cages in the middle slide, those are called oyster grow cages. And that cage right there, they're flipped up in the drying position. We do that every couple of weeks. We dry them for 24 to 48 hours and then flip them back down. Next slide. And you can see those together out on the lease. The ones in the upper right are the oyster grow cages in the growing position. The Zapco tubes are shown in the left as the tide is just coming in or going out. I'm not sure which in that picture. Next slide. So one of the problems we had as we got into the oyster grow cage system was we were originally flipping these all by hand, standing in a cage along the side of a boat, flipping them by hand. Well, we realized that you just could not take enough ibuprofen to make that work for your workforce. So we designed this thing, which is really analogous to a tractor on a regular farm. Next slide. And in the middle of it, we have, and that's another video, Alicia. So if you can get that video going, that one I think should stay upright. So this is hydraulically driven. The cages come into the space between the two hulls there, and that flipper flips them over up into the drying position. Next slide. So in the fall, when the water is starting to cool off and we're starting to worry about ice coming, we put this ramp in between the two hulls and drop that down. It's about 20 feet long. So the bottom end of it kind of drags along the bottom, and we take the caps off the floats on the oyster grow cages. They slide down that ramp and are delivered kind of like a Pez machine to the bottom, and they stay like that for the winter. Next slide. And then in the spring, we have hydraulic winches on the top of that frame on our C tractor, and we pull those up and off we go again for the next growing season. Next slide. So one of the problems is that upper Damariscotta River, historically, although the last few winters, it hasn't been so much the case, we get a lot of ice and it freezes over, and it makes it quite problematic and unpredictable as to whether you can harvest. Plus, you wouldn't want to have all that gear up on the surface where the ice can damage it. So we have what we call the seasonal oyster migration, where we tow these big long strings of cages from the upper Damariscotta River down to Peters Island at our winter site. Next slide. And you can see we harvest those oysters at that site, and that's why we did it. We can harvest year round. So we literally harvest and process and ship oysters 52 weeks a year. And that was a big game changer for our business. Next slide. Those oysters are brought in by a flatbed truck in those blue bins that you see at the bottom. There's a loading dock to the left down there where the light's coming in. They go through a washing machine, which is right behind the guy with the blue bin. And then they go, after they're washed, they go onto a sorting table where we sort them by size and call any empty shell out. I call this the Fred Flintstone method. It's by hand. This is a great story. And when the pandemic hit, just before the pandemic hit, we had ordered a sorting machine, which does it digitally with photographs and weight. It sorts the oysters for you quite fast, supposedly. But you'll never guess where we ordered this from. Yes, it was Wuhan, China. So we didn't see the machine until earlier the last year. And of course, we couldn't get any of the technicians who were supposed to come over and help us set it up, and that hasn't happened. So we're still doing it by hand, but we're working now that the Chinese New Year is over, we're working to get the thing up and running. Next slide. So before I start talking a little more about climate change, that gives you an idea of our process. I wanted to talk about some of what we call environmental services of oyster farming. So oysters are really big filter feeders. They pump a lot of water through their bodies, which improves water clarity. They feed on the phytoplankton that are growing on excess nutrients that are coming into the nearshore coastal waters because of the greater number of big rainfall events that we have. They enhance, and their feces go to the bottom. They enhance secondary productivity, which means that it provides food for worms and other things, and those are fed on by fish. There's overall an enhancement of biodiversity both in gear grown oysters as well as oyster reefs that are growing the bottom. Our gear in certain cases and oyster beds can reduce shore erosion. And we find that the floating gear traps trash. So we're always removing garbage from the Narrowscotta River that's collected on our gear. And then also, as you'll see further down the list, every year, all the oyster farmers in the Narrowscotta River get together and we do a cleanup where we take our boats up and down the river.
I don't know.
And I would say that basically farmers, in order to be an oyster farmer, you de facto have to be a vocal advocate for water quality because our livelihoods depend on having clean water. Next slide. So I want to describe a little bit our first encounter with the impacts of greenhouse gases on our operations. And it has to do with ocean or coastal acidification, which is really the process of, globally, you have these elevated carbon dioxide levels in the atmosphere. About a third of the carbon dioxide emissions wind up going into the ocean. And when it dissolves in the ocean water, it forms carbonic acid. And to make a long story short, it's fairly complex chemistry. And we actually monitor this all the time now. But basically, it makes it very hard for the oysters to make their shells. The lower the pH, the more acidic the water, the harder it is for them to make shells. So we basically saw what I would call a tipping point. It was certainly a wake-up call for us in 2009 when we were seeing really poor conversion from egg to the early larval stages. In some cases, we would have to throw a spawn out. Usually what we were seeing was that the larvae would stop feeding, we'd see poor growth and a very protracted larval phase. Normally it should take 14 to 16 days. We had some that went out as long as 3 weeks, which is way too long. And what the other thing we noticed was that it was correlated with large storm events and runoff and drops in salinity. So as a result of finally, after that season, we realized and figured out, actually with some help from some farms that had experienced this on the West Coast, we basically now buffer the water that we grow all of our larvae in. We adjust the pH every time we drain and refill a tank with water that's at the appropriate pH. And you can think of that as like putting Tums in the water. That's not what we use, but it's the same idea. Next slide. So in addition to the obvious impacts that we felt from the more frequent and intense storms, next slide. We also, there are other effects of this increased runoff with these bigger storms that we're having. On the left, there's a graph that shows what they're called Area 500 harvest closures. The state of Maine, the Department of Marine Resources, if a growing area is affected by 2 inches of rain in a 24-hour period, they close those growing areas in that area. And then they go out and they sample the water and they want to make sure that there's no influx of bacteria that are get people sick. So it's a really important safety process. But this graph on the left is basically a classic climate change graph. It shows the number of Area 500 closures that we experienced up until last year. And you can see how the trend line looks. And we were noticing this back, in the 2013, 2009 through 15, and we were trying to figure out what we could do about it. Well, we wound up building a new facility, and that's pictured on the right. You can see oysters in those black trays. This facility allows us to put oysters in those white tanks. They're stacked up 3 high, and underneath the floor there's a 26,000 gallon tank with a whole lot of equipment for recirculating the water. So we maintain an inventory in this system. It allows us to isolate those oysters from the Damascotta River in anticipation of a closure, which we do. And we close off the inflow. And then it allows us to continue harvesting throughout that closure. And we were at a point where some of these closures were costing us literally, anywhere from $30,000 to $60,000, during a single closure, which could last up to a week. So it was a really big deal. Next slide. And so those are the things that were really, making us sit up and take notice about climate change. And while I was, this was quite a bit before all of this. I remember reading these U.S. climate assessment reports. This was back in the early 90s. And the thing that I find so compelling and really struck me, is that the scientists were really accurately predicting these greenhouse gas emission effects that we have just described. And next slide. And now those same scientists, some new and younger ones, obviously, are telling us that that we risk catastrophic sea level rise, large areas of the world that are too hot or too dry for humans, and ecosystem collapses that will threaten our very survival as a species. And in order to avoid that, we really need to try to keep global warming below 1.5 degrees centigrade over pre-industrial times. We're right now at a little over 1 degree centigrade. To be on track to achieve this, we need to see a 50% emission reduction by 2030, which is only 8 years away. And when you're my age, that turns, and some of the ages I've noticed on the screen, that literally is an eye blink. So, so clearly we should be paying close attention to what they're saying now. Next slide. And I'm going to now go through the fear part of the talk. I'm going to talk about the effects that we're seeing and that we will see going into the next couple decades. So sea level is obviously a really big one. It's driven by melting ice and warming oceans. If you look at the two graphs on the right, one shows a 13% decline in polar ice extent over, I guess it's from 1984 through last couple years. The graph on the bottom shows the Gulf of Maine warming, which is one of the fastest warming areas in the world, but seawater is warming up. And what happens with the warming is you get thermal expansion that is, and I can't remember how much of it's due to ice melt or polar ice melt and how much is due to warming, but both are really significant factors. And what we're already seeing, so for example, in 2018, we would have what they call a sunny day flood per year. So that would be what sometimes people call them king tides. It's a astronomical high tide that winds up flooding low-lying areas. By 2030, they're expecting a median of 5 per year, and by 2045, it could be about 25. And the thing is that this, I believe, is based on some fairly old data. There was just a study that came out that is predicting a 10 to 14 inch rise by 2050, which is actually a lot of rise in a fairly short period of time. I believe it's faster. So that would rewrite that trend that I just described to you. And I can't resist putting the picture in the bottom, and I know you can't read it, but I'm going to tell you what that little red sign at the bottom says. It says it's a no wake sign for cars. And it's down near Barnegat Bay, New Jersey. And it was a colleague of mine has an oyster farm down there, and he took this picture and used it in a PowerPoint talk. So I'm using it again because it really shows, how this has started to affect people who live in these low-lying coastal areas. Next slide. Hurricanes. They're seeing a 10% reduction in speed due to the fact that tropical circulation is weakening, so that the winds that carry and drive the storms are slower. And that's that 10% reduction is between 1949 and 2016. There's also a lot more atmospheric water vapor because of the warmer seawater temperatures, the warmer atmospheric temperatures. And the consequences, are that you get big hurricanes like Katrina and Harvey. They're 3 times more likely. You have storms form and intensify faster, which gives people less warning. 30% increase in the peak rain rates over the last 60 years. And they're more destructive because they're slower, wetter, and they occur with less warning. Next slide. Storms, heavy floods, or heavy rains and floods. This number kind of blew me away, and it kind of matches up with what we saw with the rainfall closures for shellfish harvesting. The Northeast has seen a 317% increase in rainfall, over 150 millimeters per 24 hours between 1979 to 2014. And that's kind of the time frame that I've been operating in. And we certainly were noticing it, and it's really true. And that's from the Journal of Hydrometeorology, published last year. Next slide. And then, of course, there's just, the problems with flooding. This is from an article that was published in the Stanford University Press News last year ago, January. And basically, the message here is that about 1/3 of the cost of flooding damages in the past 30 years are due to climate change. Next slide. Heat waves. Heat wave, by the way, is defined as 2 or more days of temperatures above the historical average for a given area. So it's going to be, the temperatures are going to be different if you're in Death Valley versus Maine, obviously. But basically, if you look at the period from, say, 1850 to 1900, there was one of these heat waves a decade. And you can see from the graph on the left how those increase with different levels of global warming. So at 1 degree, we're up almost to 3 a decade. 1.5, you get over 4, and it goes all the way up. If we, God forbid, we hit 4 degrees, you're looking at as many as 9 on average per year. Next slide. Oh, one other thing. Sorry, Alicia, can you go back? Does everybody remember the heat wave last year? I mean, these things are really deadly. They supposedly kill, and I'm sure it's multiple billions of shellfish died. That's all dead mussels. In British Columbia, and it killed almost 3,000 people. So these are really no laughing matter. Next slide. And then there are a whole host of subtle changes. I talked about ocean acidification. Harmful algal blooms are called HABs, and they're starting to link those with the heavy rainfall and excess runoff. There are range shifts in diseases. We've seen that with a disease that nearly wiped out the Damascus River industry in 2009 to 2010. Invasive species. There's decreasing primary productivity in the Gulf of Maine. We now have to make very sure that when we're harvesting this summer, that our oysters are gotten into mechanical refrigeration really, really fast, because otherwise you run the risk of making people sick because of Vibrio bacteria. And then there's a bunch of other, even less obvious things. We, 2020, experienced a problem with our larvae again. And if you look at the pictures on the upper, the 2 on the upper, those are normal larvae. You can see food in their guts and in their digestive gland. If you look at the ones from 2020 down below, you'll notice some food in there, but they're basically constipated. The food is not getting out of their gut. And we discovered that that's because of polyunsaturated fatty acids, which are good things that are produced by a lot of these phytoplankton. That's what, that's the good food why you eat seafood, basically. But for some change in phytoplankton composition or some stressful environmental parameters that cause the release of those, we're seeing those being oxidized. And what happens is we're pumping some of the oxidation products of that in, and we're further oxidizing it, and that's what is irritating and actually killing cells inside the guts of the larvae, and causing them to stop eating, and basically we weren't able to grow larvae until what was interesting is we were able to kind of solve the problem as a workaround by turning off our UV, because what was happening was our UV irradiation of our seawater was basically oxidizing these into forms that were hurting the larvae. Next slide. I can come back to that later if people have questions about it. It's a little complicated. So now for the hope part. I'm going to try to leave the talk here with giving some sense of hope. So 1.5 degrees centigrade is still possible. And Alok Sharma, who is the president of COP26, I heard him on an interview with NPR, and he's quoted as saying, we've managed to keep 1.5 alive in COP26, but the pulse is weak. So next slide. So because of the urgency of this situation, I think we have to throw out the old saying of think globally, act locally. We need to think and act globally and locally. And So I think that means we need to be really serious about renewables. We need to, as individuals and as a government, we need activism. We need to engage in conservation and carbon removal, and we need to be really focused on education. And if you hit the, yep, there it goes. I thought this was pretty tricky. The way I ordered those is because we are definitely in a race against time. So next slide, I'm going to go through how we as a company have tried to conduct that race. So I'm going to start with renewables. Those are the inverters that we have for our, we have 282 solar panels on the roof of that new building, produces about 1/3 of the electrical energy we use. Next slide. We are a founding member of the Shellfish Growers Climate Coalition, which is a partnership with the Nature Conservancy. And we're basically involved in trying to convince people in the government that we need to have climate action. If you hit the forward thing, and a couple things are going to pop up, Alicia. There you go. Hit it again. So basically through this coalition, yep, go back one. Basically through this coalition, we're pushing for federal climate action. We meet with our congressional delegations. The coalition has over 250 members. We have members from every part of the US coastline, continental US. And we all descend on Washington once a year, or at least we did before the pandemic. And then the other thing that we're really working on now is coming up with ways to educate the public about the urgency of climate action, not our situation so much as shellfish growers, although we use those stories to kind of make the point, but the urgency that our government really needs to take climate action. Next slide. And then we also do a lot, or try to do a lot with conservation. The water that supplies that new building comes up from the hatchery underground. We've set that up so that we can either heat or cool the water slightly using groundwater temperature. In the middle slide, that's a protein skimmer or a fractionator. It allows us to recirculate more of the water, reuse it, and control water quality. It improves water quality, so you can do that. And then that maze of ductwork on the right, that's the heat recapture system for our clean room, which is maintained under positive air pressure, so we can keep all of our cultures perfectly sterile. Next slide. And then I'm going to leave you all with this final thought, and that is that, the evolution of abstract thought and imagination in the human brain got us into this mess, very definitely. Those things are certainly going to be needed to get us out of it. And that doesn't necessarily mean all high-tech things, but for example, carbon sequestration, capture, and reuse. There's an awful lot that can be done with nature, and that's growing trees. We need to be aware of the trees that we're cutting down, because there's a lot of carbon stored in those. And new technologies such as hydrogen and fusion, there's a lot of press right now about fusion power. However, there's not a milliwatt of power that's been produced by that, but there are a lot of very smart people working on all these things. So, some of these things are going to pan out. I mean, who thought we could have enough power in our cell phones to get us to the moon, when those first arrived on the scene? So I think we have to be optimistic, and we have to have a positive attitude. And I'll stop there. I'm absolutely, I guess I'm sort of on time, but I hope that we have time for a few questions. Thank you.
You did really great, Bill. Nice recovery.
Well, I started to race through it so much, but anyway.
That was wonderful. So I'm going to ask you folks that are out there, your living rooms and kitchens, if you all have any questions, you can communicate directly with me via the chat room. And I will pass them on to Bill. Bill, I have a question for you. What has been the most challenging aspect of raising oysters on the Damascotta River, say in the last 5 years?
Well, I think probably I would say two things. One is we had those production problems that I described. That was incredibly stressful. To say that it was a hard time is a bit of an understatement. And then I think, the impact of the pandemic was really rough. I mean, in March of 2020, our sales dropped by 90%. And we had no idea when they were going to come back. They did kind of rebound in the early summer, but it was really up and down as every new variant showed up. We would see things change. And the problem with oysters is that they are primarily eaten in restaurants. And so, all the food service distributors that we were supplying, their business just shut down. The thing that I think we were doing before it hit, and we were so glad because we did sort of lean on it, is we sell oysters to Whole Foods. And that's was a great outlet because people could buy oysters and take them home that way. And they bought enough, so it was a significant amount. And we've actually been expanding our sales to them.
Right. Bill, this is a question. If you could talk a little bit about the machine or the crane that you built to flip over the large growing trays. Why did the trays need to dry out on one side?
So what you're doing is if you were to leave those cages down in the water so the oysters are held in 6 bags inside that wireframe cage. And if you left that down in the water and never flipped it up to dry, you would have all kinds of stuff growing on there besides the oysters. You would have, seaweed and bryozoans and all kinds of invertebrates. You'd have, and it basically restricts the flow to the oysters. So if you periodically flip it up and let it dry out, just like lobstermen pull their traps out and dry them, but we do that on a regular basis. And depending on the time of year and the temperatures, we can leave them out of the water for up to about 48 hours. And of course, the nice thing about those Zapco tubes is it doesn't require anything from us because it's a passive system. When the tide comes in, they're submerged. When the tide goes out, they dry. So they're drying, a couple hours a day at least every day.
Another one for you, Bill. You well described the issues that you face, and how do other local organizations help, say, Darling Center and Coastal Rivers?
That's a really great question. So when we have a technical problem like that, we do have a fair amount of biological expertise on staff. However, that problem that we described, what we did was we reached out to the Darling Center, Bigelow Laboratory, several people at the University of Maine who have science expertise in relevant fields. And we put together a team of people who agreed to sort of help advise us. And we would give them briefings, ask questions, tell them about all the experiments we were doing. And it was extremely helpful and without question guided us to some of the answers that we were seeking.
Bill, do you ship the bulk of your oysters out by land, air, or water?
By land. We have a truck that goes to Boston probably 4 times a week. We try to take other people's oysters or whatever else we can. We've even hauled tofu to Boston. But yeah, it gets trucked down to Boston, and then in Boston there are freight consolidation terminals where you can get it on other trucks that go to every metropolitan area in the country.
How long does it take to grow a commercial oyster?
That's a great question. When I first started back in the 80s, you would have to figure on 2 winters. After the second winter, you'd be able to start harvesting those oysters. Because of selective breeding, because of probably warming water temperatures, and also because of the growing technology that we use now, we are predictably starting to harvest a crop after about 14 months.
Oh. All right. Bill, how do you strike a balance long-term between expanding the oyster farms on the river and the increase in recreational boat traffic?
Well, it's a tough one. We try to, well, by law, the way the aquaculture lease statute is written, the state has to determine, in order for a lease to be granted, that you are not unreasonably interfering with pre-existing uses. So basically, if you look at where we've selected, those are areas that are not typically, traversed by boats. There are boats that go through there, and there are still boats that can go through there. So sighting is really a big thing.
Bill, what are the names of the oysters that you sell under?
Primarily, we sell under the Moon Dancer label, and also we sell they're called Mookie Blues, which is a trademark name that we sell to Island Creek, which is an oyster company down in Massachusetts.
How many oysters do you take out of the river annually?
Well, it's a lot less right now after the pandemic. We had reached a peak of about 4 million oysters a year.
Awesome.
Maybe I'll talk a little bit, if people want to hear this, just about the workforce and what the aquaculture industry in the Damariscotta River has accomplished in terms of bringing in young people. So if you look at that area from Glidden Ledge up to past the Route 1 bridge, I think it's about a 5-mile stretch. And there are, I think, 8 or 9 different oyster farms of different sizes in that stretch. And there are somewhere between 85 and 100 people directly employed by those farms. In addition to that, we have the river tripper that takes people out to tour the oyster farms in the river, and you have Brendan Parsons' shuck station. So, and all the local restaurants serve the local oysters. So, but the thing that I have found most exciting is that of that 85 to 100 people, you're looking at the oldest guy in the whole crowd, right? It's really a lot of young people. We have, young families that have come in and bought homes and are living in our area now. And, people, who are educated. We hire and employ people of all educational backgrounds. So it's just a really exciting thing to see these young people come in. They have a real passion for this work. And, but some of them are starting their own businesses. It really is something that we need to see. When you go into Lincoln Theater, and I include myself in the group, the hope is that someday it's not going to look like a bunch of Q-tips in there, right? that you're going to have some people with actual blonde hair and brown hair too.
Here's a question for you. How can I help with climate change using the real practical information that you provided?
I think spreading the word. Again, we have 8 years. I mean, this is a really big deal. The picture that I provided Alicia for this talk, I'm holding my 3rd grandchild on my lap. That's why we need to do this. By the time it gets catastrophic, I probably won't be here anymore, but they will. And so I feel that educating yourselves, learning what you can, reading about it, talking to your elected officials, and by all means vote. And I'm not somebody who's big on a litmus test for somebody, seeking elected office, but, if there ever were a time to have a litmus test, I don't care if somebody's a Republican, Democrat, Green, or whatever party they are. What I care about is that they understand the importance of this. And, I'll vote for a Republican if they have a better agenda when it comes to climate action, because it kind of, in my view, and from what I know and what I've seen, through all these years, this is a real thing, and it's getting worse. We're at a point now where we're seeing an acceleration of all these things as the different feedback loops start kicking in. So I just think that everybody can play a role. Look at if you don't have a place you can put solar panels on your house, you can buy into a solar farm. There's a lot of things. Conservation. From insulating your house well to getting a fuel efficient vehicle or a hybrid or whatever. I think there's a role for everybody to play. But I would also say individual action is not going to solve the problem. We have to push for public policy and make our government hold our elected officials' feet to the fire and say, we want a livable biosphere for our grandchildren.
Bill, you talked about the attraction of younger people and employment, and will you chat a little bit about the community on the river and how oyster farmers collaborate or compete with one another?
So in the early days, I will tell you, it was not a collaborative atmosphere. I think one of the things that the younger folks who've gotten into the industry have brought with it is a much greater sense of collaboration and community and collegiality. And it has, I think a bunch of us old guys have really latched onto that. So we get together when there's a crisis. We've always gotten together, whether that's a closure in the river that finally led us all to start the Tidewater Watch up at Lincoln Academy, and with shoreline surveys that cleaned up overboard discharges. That was an example of first time. But now we do this. We all get together and do the cleanup. Everybody brings their boats and trucks, and we haul a lot of stuff out of there. We also got together and formed a group that, with the idea of trying to market Damascus River oysters as kind of the Napa Valley of oysters, if you will. And we had a couple of great celebrations, and then the pandemic hit, and so hopefully when things return to normal, we can get back to that. That was a lot of fun. The local news, Todd Guttner, the weatherman on Channel 6, he was the MC for the oyster eating contest. It was a lot of fun, and it just brings all the oyster growers together. And we certainly, I think the message that we're trying to give to each other is, there's a lot of room to grow the market for oysters. Historically, there were way more oysters consumed per capita in the US in the late 1800s and early 1900s. And we're just getting back to that now. We're not even there yet. France produces 10 times or more oysters than we do. And, and we have a much bigger market than they do in North America.
It's going to be your final question, Bill.
Okay.
What is the effect of red tide on oysters as filter feeders?
So oysters grow typically in areas where red tide is not often a problem. So for example, we have never experienced an actual red tide closure in the upper Damascus River. But further down below Glynn Ledge and down in the colder parts, that is an area where there have been closures, but that's not a great place to grow oysters. There are other harmful algal blooms, however, that have been closed, and sometimes for a pretty long time. So that is a problem. I kind of feel, because of the temperatures and the oceanography of the Damascus River, we're probably good on that particular harmful algal bloom, but there may be others that crop up that we're going to have to be watching for. Well, I just want to apologize again for the technical glitch. Thank you all for hanging in there. I appreciate it. I'm not sure I still understand what happened, but I'll figure it out on my own time.
Oh, Bill, I can't say thank you enough. And to all of you beautiful faces out there, thanks for being here tonight. And we'll see you on March 10th, I hope.
Excellent. Take care.
Bye,
Thank
Bill.
you, everybody.
Thank you.